BINTI AHMAD Zulkarnain, and my metric number is 288057. In this video, I'm going to explain about question 1 for my calculus individual assignment. The question is, discuss and sketch the following function fx equal to cos x, where x is greater than or equal to 0 and x is less than or equal to 2 pi. So, we need to find x-intercept, y-intercept, vertical and horizontal asymptote of an interval where the function is increasing or decreasing, x-coordinate of inflection point of an interval where the function is concave up or concave down, maximum or minimum point, and lastly, sketch the graph. Firstly, we need to find x-intercept. To get x-intercept, we need to set the functions equal to 0. Then, we solve the functions and we get x equal to pi over 2 and 3 pi over 2. Thus, the conclusion is x-intercept is at pi over 2 0 and 3 pi over 2 0. Next, we need to find y-intercept. To get y-intercept, we need to set x equal to 0. After we solve it, the answer that we get is undefined. Thus, there is no y-intercept. Then, we need to find vertical and horizontal asymptote. For vertical asymptote, as we know, the function cos x is equal to 1 over tan x, which is equal to cos x over sin x. Thus, we need to equal the sin x into 0. Thus, the x that we get is 0, pi, and 2 pi. The conclusion is the vertical asymptote is 0, 0, pi 0, and 2 pi 0. Next, since cos x is periodic, thus it does not have horizontal asymptote. Next, we need to know whether the function is increasing or decreasing. To know that, we need to find the first derivative of the functions. Next, we need to equal the first derivative into 0. Then, after we solve it, we can get the critical point. But for this question, we cannot get the value of x because sin x cannot be equal to 0. Thus, we need to use the value of x besides 0, pi, and 2 pi. So, refer to the table. When the x is equal to pi over 2, the first derivative is equal to negative 1, which is the first derivative is negative and it is less than 0. Thus, the function is decreasing. Next, when x equal to 3 pi over 2, the answer is also the same. Thus, the conclusion is function is always decreasing on 0 to 2 pi. Then, we need to find x-coordinate of inflection point. To get that, we need to set the second derivative equal to 0. After we solve it, the answer that we get is x equal to pi over 2 and 3 pi over 2. So, the conclusion is the inflection point is pi over 2, 0 and 3 pi over 2, 0. After that, we need to know whether the function is concave up or concave down. Based on the theorem, the function is concave up when the second derivative is greater than 0, and the function is concave down when the second derivative is less than 0. So, refer to the table when the x is equal to pi over 4 and 5 pi over 4, the second derivative is positive, which is greater than 0. Thus, the function is concave up. Then, when x is equal to 3 pi over 4 and 7 pi over 4, the second derivative is negative, which is less than 0. Thus, the function is concave down. So the conclusion is the function is always concave up at pi over 4 and 5 pi over 4, and the function is always concave down at 3 pi over 4 and 7 pi over 4. Next, we need to find the maximum or minimum point. To get maximum or minimum point, we need to find the critical point first. Thus, we need to set the first derivative of the functions equal to 0. But as I said before, for this question, we cannot get the value of x, since the sin's x could not equal to 0. So the conclusion is the function does not exist when x equal to 0, pi and 2 pi. Thus, there is no maximum or minimum point. After the point that we get, and this is the points, then we can sketch the graph of the function. So this is the graph of the functions that I sketched with the point that we find. That's all from me. Thank you and bye.